Question number 3, we have a diagram here. The diagram shows two graphs with equations y equals to fx and gx. Describe fully the sequence of two transformations which transform from fx to gx. So this right hand diagram is fx and gx. So our transformation is like this from here. This side is fx and this side we have a gx, right? So we are looking for this transformation. Now first of all, if you observe the diagram, if you see the diagram along this horizontal, this remains the same. You see this one here is 2 squared from here to here, and this also is 2 squared here. So that means there is no change in along x-axis, right? So if we see that change along y-axis, if you see the diagram from here to here, this one, and from here to here, you see, so here we have 1 2 3 and 4 squares. Here we have from 1 2 3 4 5 6 7 and 8, from this corner to this one and this one to this one. So you can see this has been stretched, right? So this is 4 and 8. Now we can see the other part also from here to here. This is 1 2 from this point to this point. So 1 and 2 squares. Here we have 1 2 3 and 4 from here to here, this one, right? So if this is 4, this is now 2. So if you can see, this has been stretched by 4 squares, that is a vertical stretch. So we will write it down. So we got the first transformation that we have. It is a vertical stretch, along y-axis with the stretch factor of 2, right? Stretch factor is with the stretch factor 2. Okay, now we will see the second transformation. Now what happens when it is stretched? So then this part is this part came over here, let's say, then this part after stretching it came over here, right? And then this one here, it is like, if this is here, let me use other color, you can see nicely. Let me take the dark one. So we have this one here, this is 3, stretch factor is 2, 3 times 2, it will come over here at the 6. So this point which is at 3, so it came over here, so the diagram become like this. And the other this corner here, this is -1, right? -1 times 3 it will become, and times 2 it will become -2. So this point is came over here. So we will join the line like this, right? So then after this point we have here -3, right? So this -3 times 2, -6. So this point is going to come over here. So the graph is like this. You see, this is after the stretch, right? Now you see this point, actually from here it goes 1 2 3 4 5 and 6 units. So 6 unit towards left hand side, so it is -6. So we can write down here the second one, it is a translation. So how it is translated? So it is a translation along vector -6, and there is no change in y-axis, you can see, because after the stretch it automatically came over here. So this have not been moved up and down, so it is just on the along the x-axis. So x coordinate is for vector is -6, right? Now number 4, we have a question here. The diagram shows a sector of a ABC of a circle with center A and radius 8 centimeter. Radius is 8 centimeter. This is part of the circle. The area of the sector is given to us. The point D lies on BC, arc BC. So D is on arc BC. Find the perimeter of the segment BCD. So for the perimeter we need to have the length of arc BDC, plus we are going to find out the length of this line BC. So basically we need this length and this length, right? So for that we have to find out first of all angle theta. So what is angle theta? So let's see. Angle theta, we can start from the given thing. We are given area of the sector. Area of sector is 16 over 3 pi, right? And then formula of area of sector is half r square theta equals to 16 over 3 pi, right? So r we don't know that is 8, so it is 8 times 8 theta equals to 16 over 3 pi, right? So now this from here 8 times 8 64, this will become 32 theta equals to 16 over 3 pi. So theta is 16 over 3 pi times 1 over 32. So 16 times 2, theta is pi by 6, right? So theta we got pi over 6. So then from here if we know the theta, then we can find out the length of arc. So length of arc BDC will be r theta. R is 8 times theta is pi over 6, and if you calculate this comes out to be 4.1887. Directly use the calculator. So this is the length of arc BDC, right? So this we are going to use later. Now we need BC, right? To find out BC we will use the cosine rule. By cosine rule, let me show you how you are going to use cosine rule. We will take this triangle ABC. So this is 8 centimeter. So by cosine rule we can find out length of BC. So BC is equal to, so it will be BC squared equals to 8 square plus 8 square minus 2 times 8 cos pi by 6, right? So this is 64 plus 64 minus 2 times 8 64. Cos pi by 6 is root 3 over 2. Then 2 and 2 gets cancelled. So this is 128 minus 64 square root 3. So then we can find out BC. When you find BC, then there will be a square root of this. Just put in all these values in the calculator. Then I got here 4.1411 centimeters, right? So this is BC. This is, let's say, number 2. So we need both of them later, right? So now the perimeter, we are going to add these two. So the perimeter we have already written here. The perimeter is going to be length of BDC plus BC. Length of BDC from equation 1 we have here 4.1887 plus BC is 4.1411. So this is 8.3298, and approximately it is 8.33 centimeter if we take it to 3 significant figures, right? So this is our final answer. I hope you guys understood. Kindly subscribe to the channel and share it with your friends. Thank you so much, guys. Be blessed.